All right, guys, this is our very first section of our very first chapter. So chapter 1, section 1. And these are some review topics, but sometimes you forget things over the summer, so it doesn't hurt to review some of these things. And there's two things we're going to talk about in this section. We're going to talk about the Pythagorean theorem, and we're going to talk about the distance formula. If you remember the distance formula well, you remember, wait, isn't that just the Pythagorean theorem again? And it is, but we'll see to that when we get to it. So I want to start with the Pythagorean theorem, and you'll remember this, I hope. You've seen it since probably middle school. It talks about Pythagorean theorem in a right triangle. So not for every triangle, but in a right triangle, if you've got your legs A and leg B, so legs A and B, and your hypotenuse C, then you know A squared plus B squared equals C squared. And again, this goes back over 2,000 years of Pythagorean theorem, so it's kind of a neat theorem and useful if given two sides of a triangle. So look, here's a 6, here's a 10, here's a right angle. The little box shows us the right angle. We can find the third side. When we're looking for that third side, how do we do it? We use the Pythagorean theorem. And so it goes A squared plus B squared equals C squared. Definitely the side opposite the right angle. You have no choice on that. That's side C. The other two, take your pick. One is A and one is B. It doesn't really matter. Let's call that A. Let's call that side B. And we'll use the Pythagorean theorem. So A squared, 10 squared, plus B squared equals C squared. So 10 squared is 100. 6 squared is 36. 100 plus 36 is 136. That equals C squared. And then we need the square root. So our final answer is the square root of 136 equals C. And you might think with a square root, don't you take plus or minus? You do, but we're finding a measurement, a length, and lengths are always positive, so we leave it like that. Other things hopefully you're thinking are, or another thing you should be thinking is, can't you simplify that square root? And you can. So you look and say, what goes into 136 that you know the square root of? And it turns out 136 is 4 times, got to think through this one, 4 times 34, is that right? 68, 136. And we know the square root of 4 is 2, so I can call this 2 square root of 34 equals side C. This would be the exact answer. 2 root 34 equals C. You might want to pull out your calculator and get a decimal approximation because we know one side is 6, the other side is 10. The hypotenuse is going to be a little bit bigger. Maybe you're guessing, 11 or 12, somewhere in there. That would not be a bad guess. So let's just pull out our calculator quick and get an answer for this. Oops, that's not my calculator. Let's try that again. Where did the calculator go? Let's try this one down here. All right. So pull out our calculator, and we want the square root. So go second square root. And we want the square root of 136. And let's get that answer. We can do a couple things here. We can hit enter. This is kind of a fancy calculator here. And it gives us the exact answer, 2 root 34. Or if we hit control enter, it'll give us a decimal approximation, which is 11.6619. So we can kind of hang on to those two answers. So can I move that down there? No. Let's do this. I'll take that page. And let's see, put that away, and let's see if we've got it here. There we go. So we kind of keep those two answers somewhere. And we've got 2 root 34, or 11.6619. And that is the Pythagorean theorem. And again, this is a review topic, so hopefully it's something you're familiar with. If not, it's certainly something that will come back quickly, and you'll have some in the homework to practice these. All right, let's try it again. Take a look at this next problem, and you might think, wait, isn't that the same question? There's a 6, there's a 10. Yeah, it looks like the same question. But it's not the same question because, look, this time, you look at your right angle. Opposite the right angle is your hypotenuse, which is the 10 this time. And the other two are your legs, so let's call this A. Let's call this one B. And we've got A squared plus B squared equals C squared. That's the Pythagorean theorem. So we've got a 6 squared plus a B squared equals a 10 squared. So we've got a 36 plus a b squared equals 100. Take off 36 from both sides. B squared equals 64. And look how nice that is. Take the square root. And b equals a positive 8. Okay, and again, you might remember these from geometry. There's certain special Pythagorean triples. If you had a 3 and a 4 for your legs, the hypotenuse could come out to be 5. If you ever double those, look, we get a 6 and an 8 and a 10, which is a triangle we just had. So you could take them times 10 and have a 30, 40, 50. Take it times whatever, 5, get a 15, 20, 25. So there's certain Pythagorean triples that come up a bunch. So that 10 and that 6 you may have remembered and said, oh, that's part of the Pythagorean triple. If you didn't remember it, no big deal. It's not hard to figure out with the Pythagorean theorem. Okay, hopefully you're enjoying this. Hopefully you're getting this down and saying, this is easy. Let's try it one more time. Here's another triangle. We have one side is 7. Oops, one side is 8. One side is 7. Let's get the third side. It certainly looks like this third side is the longer side. And if you begin to write a squared plus b squared equals c squared, hopefully you'll catch yourself and say, wait a minute. I'm using the Pythagorean theorem. I'd like to use the Pythagorean theorem, but it only works for right triangles. So it's important to remember that. Oops, get this goofy picture out of the way. Pythagorean theorem is only going to work for, right here, look, it works for just right triangles. So if they give you any random triangle here, the Pythagorean theorem does not necessarily work. And so I've got a 7, I've got an 8, but nowhere in here, none of these angles are they telling me it's a 90-degree angle. None of those angles are right angles. So I can't apply the Pythagorean theorem in this particular problem. And so make sure you don't get fooled and over-apply the Pythagorean theorem. It just does not apply to this problem. Okay, one more thing about the Pythagorean theorem. It works backwards. And backwards, what we're going to say, in math, we call that the converse. So if in a triangle, you look at the sides and you notice side A squared plus side B squared equals side C squared, then you can say this is a right triangle. So if you've got the measures of the three sides and you notice that property of them, a squared plus b squared equals c squared, then you now know that there's a 90-degree angle. And specifically, the angle would be the angle opposite the longest side. So let's try this a couple times. Here are the measurements of sides of a triangle. One side is 5, one is 13, one is 12. Let's pick off the two shorter sides. Let's go with 5 squared. Let's go with 12 squared. And let's see, is that going to equal 13 squared is the question. If it does, we know that's a right triangle. So let's try it and see. 5 squared, 25, 12 squared, 144. Add those two up. It looks like a 169 on this side. And it turns out 13 squared is 169. So does 169 equal 169? Yes, it does. So this is a right triangle. So that one's a right triangle. All right, let's try it again. 2, 3, 4. We said a 3, 4, 5 is a Pythagorean theorem. Is a 2, 3, 4 Pythagorean triple? I don't know. Let's try it and see. What's 2 squared plus 3 squared? Does that equal 4 squared? Maybe you're doing that in your head. 2 squared is 4. 3 squared is 9. 4 and 9 is 13. Is that going to equal 16? Oops, those are little question marks there. And the answer is no. So guaranteed this one is not a right triangle. So that's our Pythagorean theorem. Second video, so this, I'll take care of our first video here. Second video is going to deal with the distance formula, but we'll pause this one here. That takes care of your Pythagorean theorem.